Hey, we're back. Okay. I've got a fun one here. This is going to be kind of a two-part lesson. I was experimenting with some fun stuff the other day, just kind of trying to learn and make something cool. And I remember there was this talk by XK Studio a while back where they kind of mentioned this sort of distance-based inflation effect that they did. And I thought that it would be kind of a good experiment to try to recreate something like that. And they didn't really show exactly how to do it. They just kind of mentioned that they did it. So I kind of had to figure this out on my own. And I had to ask for help, and I did a bunch of research and stuff, but I finally figured it out. And I think it's once you know it, it's actually really simple to do. So I thought that I would just kind of pass that knowledge on to you guys. And then we're going to be creating this thing here. There's a couple effects happening here. So there's this sort of like distance-based inflation that's happening, and I'll explain what that means in a minute. It'll make more sense. And then we're also scattering a bunch of Redshift, animated Redshift proxies, and I'm having them animate through their sequence, up and down their sequence based on a fall off. So I'm going to show you guys how to do that part in the second half. So this one will just be the sort of base Vellum simulation. And then the second half, I'll show you guys how to retime and resequence Redshift proxy instances. So you can put like thousands of animated things on here. So it should be good. Let's get started. So let's put down a geo. No, a geo. God damn it. Off to a great start. Okay, cool. And we're going to call this Vellum sim. All right. So then we want to put down a torus like this. And let's give it like a radius of 0.15 here, make it a little skinnier. Uniform scale of 1.5. Oh, nope, 1.5, something like that. And let's give it like 44 rows, 47 columns. Just give it a little bit more like that. Okay, cool. And what I want to do is then I want to remesh this so that I have triangles. So put down a remesh like this. And let's put the target size down to 0.03. So let's give it some pretty good resolution there. Okay. And then what I want to do is let's put down a null here. And then I also want to put down a transform like this. And why do I keep putting that up there? Okay. And let's put down another null. And I want to merge these two. So I'm going to show you, I'm going to set this up and then I'll explain what's happening. So we have two. Let's go like this, turn this at an angle, and then kind of move it off to the side so that it's not intersecting, and there. And then I want to put down a mirror like this, put down another null. Damn it. Sorry, it's been a long day and I can't type, but okay, so then we have this, and then I want to make sure I uncheck the keep original. And then let's just transform this one so that none of these are intersecting. So they're interlinked, but none of them are actually touching. Okay, cool. And then what I want to explain here, I'll show you in SOPs before we move into DOPs. There's this thing called distance from geometry. And how this works is I can plug in, let's say this one here, and then I need a reference geometry, which would be this one here. And it's going to take a second for some reason. Okay, so what that does, let's put down a little null here so I don't have this thing. Basically, it calculates the distance between the two, and we can visualize that with, I like using this mask. Instead of distance, I like mask. And you can see it has this little red thing here, and we can increase the radius. So basically, where this one is closest to this one, you can see there's this mask. So what we're going to do is we're going to use this mask. We're going to create this for all three of these objects, or maybe even four, so that the closer they get to each other, the more this mask is present, and the farther away that they get from each other, the less this mask is present. And we're going to use that mask as a way to define where we want these areas to inflate. So where the mask is present, I want it to like inflate a lot. And where the mask isn't present, I want it to deflate. And then, so what's going to happen is as they inflate, they're going to push away from each other. But since they're interlinked, they can never fully get away from each other. So they're going to kind of push away from each other, and then they're going to deflate as they get away from each other. And then they're going to dynamically sort of like fight each other forever and create this like really crazy looking simulation. So, the way we want to do that is, so this only gives me the mask for this one, but I would need to set that up for all of them. So I would need to go, and why does this take so long to calculate? I see, because I think I had my uniform scale set to like 4.5. I want it to be 1.5. There was just a ton of geometry. So let's reset that down to 1.5. Let's come back to our merge here. Yeah, that's what it was. Let's bring these in. It's going to be a lot lighter now because there'll be way less geo. And it should calculate a lot faster, like basically instantly. Yeah, that's better. Okay, so we have the mask there. And we can bring the radius back down to 1. And then we need to do the opposite. So if we just hit Shift R, now it's calculating this one. And if I merge these two, let's get this out of here. This is just to show you what's happening. I'm going to delete all this shit in a second, and I'll redo it inside of Vellum. Okay, so now you can see as these things are, if I click this, if I move this one, should be able to see. Turn on mask. Yeah. Should be dynamic. So if I move them, the mask changes. You can see it's getting wider over here. Cool. Okay, so I would need to set that up for all of them. So I would have to have another distance along the geometry here for, between the other one and that one. So, but that's the basis of what we're going to do. We're going to create this mask, but we need to do this if I do it outside of Vellum, it's only going to read it in on the first frame. But I want this to dynamically adjust, like as these inflate and get closer to each other, I want the mask to dynamically adjust. And so that means we have to set this up inside of the Vellum dops. So a lot of people were telling me that you have to use a bunch of code for it, and it seems really complicated, but I spent a lot of time trying to figure out a way to do it like with no code at all, or like the least amount as possible. And I figured it out. So that's why I kind of wanted to share it with you guys, because there is a way to do it without code, and it's actually pretty easy. So the first thing we're going to need to do, though, is we're going to need to set up a Vellum balloon thing. So let's just type Vellum balloon, Vellum configure balloon. Okay, let's plug this first one in, and let's see what we have here. So I think that I'm trying to look at the settings here. Set uniform. I think that's all okay. Trying to figure out what I compare it to what I had before. The stiffness, I think I want my stretch stiffness to be 1, and so that it's a little floppier, because I really want this to be like, I want this to be explosive. I don't want it to look like just a balloon that's inflating. I want it to look like really abstract. So I want this to be able to stretch a lot. And then the bend stiffness, I believe I lowered this down to like all the way to the bottom, basically. And then output group stretch. Yep, that's all the same. Okay. And then let's put down a null. And we'll plug it into the first thing here. We're going to call this geo. And then let's plug this into the second one here and call this constraints, or just con. Okay, great. And then let's just grab all this, copy it, and plug this one in here. And grab all this, copy it, plug this one in here. Okay, cool. So now we have 3 separate things. So I found that I was trying to do this with the typical like Vellum solver, the SOP solver, like people normally do, or people do lately. And I was having trouble doing it. So I kind of had to go back to the old method of doing it. It was a little more clear for me to do it that way. So I'm going to show you how to do that. So just put down a DOPNet. We'll call this Vellum sim. And then inside the DOPNet, we need a Vellum solver. We plug that in here. We need a Vellum object. Okay, like that. And then we need a vellum source. Okay, we need a vellum source for each one of these things. So let's put down like that. We'll call this 1. No, I guess I can't do that. Vellum source 1, 2, and 3. That's fine. Or just let's say, let's go left, middle, and right, just so that it's easy to kind of distinguish. So, reft. Okay. And then what we would do normally is you would merge all these and put them in here. So let's set this up. So with the vellum, in the vellum object, I don't believe that I need to change anything, but for these, I do. So let's come back up. Let's copy. So this one is left, this is middle, and this is right. Okay, so we have geo. Let's copy that. So on the left one, under the SOP path, we just paste that. And then under the constraint path, let's just paste it again, but then change this to con. Okay, so now we have that. Over here, let's do the same thing, but change it to geo1. And then constraint path, same thing, just type con1. There you go. And then on the right, same thing, geo2 and con2. So it was just a little easier for me. These have to be separate streams. You can't just put them all in as one object. These all have to be separate objects like this so they can detect that there is another object close to it. And it was just a little easier for me layout-wise to kind of see it here and visually see what was happening than it was inside the SOP solver where it's all kind of hidden. Okay, so how do we get those distance along geometry nodes in here? So if I type distance along geometry, nothing comes up because it's a SOP node. So the way that you access SOP nodes inside of a DOP like this is with the SOP solver. Okay, and let's get rid of this merge. Let's plug this here, and this here. Okay, and then I think, is there anything else I need to do on this? Nope, everything is default. So just dive in. And what I want to do is I want to separate these out. So let's get rid of this here. So let's put down a blast here. And what I want to do is blast stream left and just do delete non-selected. So now I have my left. Okay. And then let's do stream, delete this, stream middle. Oops, come on. And we'll call this middle. Okay, and then separate over here. We'll call this, god damn it, right. Okay, and same thing, we can just type right. Okay, so now we have all three of these back in here. And since we're in here, check it out, distance along geometry. We have access to all of the SOP nodes like we did before. So what we're gonna need to do, it's gonna get a little messy here, just because there's gonna be, we have to set this up for each one of these. So let's do left to middle. And then let me make sure instead of outputting dist, I output mask. Okay. And I think I want my, you can kind of change how sharp or how much this spreads or not. I think I had mine somewhere around there, but it'll give you different results based on how far you have it. But I think that's probably pretty good. Okay. So I've got that. And let's do a merge down here. Let's get rid of this and plug this in here. Make sure I have mask turned on so I can see. Okay, so I've got that one. Now I need the opposite. I need to detect how far the middle one is from the left one. So if I just hit Shift R, it switches the wires and I can plug that in there. And now I have it on this one too. Okay, and then I need to duplicate this again. And I need to detect how far the middle one is from the right one. So let's disconnect these. So I'll need to detect how far the middle one is from the right one. I don't know if you guys can hear, but my cats are just going insane in the background. Sorry if that's distracting. Okay, and then I need to detect how far the right one is from the middle. So if I need to take this and switch it like that, Okay. And then I'd also like to have this one, left one, detect how far it is from the right one. So you don't have to do that, but I think I did it. I think it helps. So let's see. So how would I do that? Oh, wait, I'm missing one here. I'm missing the middle detecting from the left. Why am I missing that? No, maybe I'm not. Interesting. Why? It seems that I am. Got middle, middle. Ah, I see. So I'm making a mistake here. I did this originally as well, and it messed me up. So I'm duplicating this geometry because I have this and I have this again, and they're sitting on top of one another, and now I can't see the other one. So what I need to do is I've got this, and I've got this, and I've got this. What I need to do is, how did I do it? So for my left one here, I'm going to start over. It's getting confusing. Get all that shit out of here. So instead of plugging in the middle one here, I want to plug in, or do a merge and plug in the middle one and the right one. So now, okay, that's correct. Great. And then let's copy this here. Delete these. For the middle one, I want to do a merge of the left and the right. So let's do merge. So merge the left one and the right one. So I've got these. And that gives me, make sure I turn on mask. There we go. Okay, so now it's not duplicating the geometry when you do it that way. And then for the right one, let's duplicate this. For the right one, I need to do, let's see, it's a little tricky here. The right one, I just need to do a merge of the other two. So basically for each one, just for whatever one you're detecting, just merge the other two, or the other, if you did 4 or 5, just merge all the ones that you're not detecting there. That should do it. So now we should have, there we go. So now we have a mask here for how far this one is away from this one. We have a mask here for how far away this one is from this one. We have that on the other side. And then we also have a mask on these edges here where these two outer donuts are coming together. Great. Jesus. Okay. It's a little complicated there just to wrap your mind around it, but that's basically it. Okay, cool. So now we have that. What do we do with that? How do I make that influence my rest length? So there's this great thing called, or actually first let's put down a pop color. So I like to do this so that I can see what I'm doing. And we're going to do a ramp. And we're going to use, instead of at NH, we're going to use mask. And that should just give us there. So now we can kind of see what we're doing as dynamically. It'll change this color. Okay. So there's this great node called Vellum Constraint Properties. And what this allows you to do is read in attributes like mask or things from SOPs or whatever, and have it influence the properties here. So the property I want to influence is the rest length scale. So basically where the parts are white, I want the rest length scale to increase so that it like expands outwards. And where it's black, I want it to decrease or stay the same so then as these things expand, they're going to kind of push away from each other. Okay. So how do I do that? Well, I need to write a little bit of code here. So you would think that, like normally the way you would do this, like if you had these attributes up in SOPs, you would just use vex expressions and you would just do a point function like point and then read in your, whatever attribute, and you can just pull your attributes right in and it works and it's great. Okay, with this, it's a little different. You'd think that since this is plugged in here, that it would automatically detect that there's a mask attribute coming in, and it doesn't. And to be honest, in my opinion, that's fucking stupid. It should totally just detect it, but it doesn't, and so we have to do a little bit of work to make it work. But it's not that hard. So in the inputs, for input 3, we need to change it to DOP data, and then here, what we want to read in is the we need to type in vellum and then star and then geometry like that. Okay. And so basically this mask attribute exists on the geometry stream of my data. So we have to be able to say, okay, input 3 is the geometry stream of the data. And this is the part that I kind of needed help with. I could not figure this out. So I had to ask for help. And this nice guy, David Torno, helped me out with this. And so thank you, David, if you're watching this. Thanks. It really helped. So this is like, you have to basically say, this is where the data lives. Okay. And then we need to do a little bit of vex to take this data here and apply it here. So the way you do that, it's not that hard. There's these two functions. There's one called xyzdist and another called primuv. And this is another thing I had to learn for this. I never really used these attributes before, but they are extremely useful. And now that I know them, it's super helpful. So they're on YouTube. This guy Voxide VFX, who makes some great tutorials, has probably the most simple and easy explanation for what xyzdist and primuv are. Both of them are functions that work together oftentimes. And so this explains exactly how to use them and what to do. Basically, xyzdist looks like if you have two pieces of geometry, xyz distance calculates the distance between the two of them. And then primuv basically allows you to take attributes from that. So it's like saying, like, if I have a sphere, one right next to each other, one of them has some attributes, and I want to transfer those to the other. Basically, it's code to do an attribute transfer. It's basically saying, like, the sphere with no attributes should look at the sphere with attributes, and then where it's closest, pull those attributes onto itself. So that's what we're doing here is we're going to be looking at the geometry, and then where the constraints are closest to that, we're going to copy them. So I don't know if I'm explaining that super well. I hope that kind of makes sense, but I would say definitely watch this tutorial. It really, really explains exactly how to do it in like the simplest possible way. It's easy to wrap your mind around it. So what we need to do is create an integer called prim that's just empty. And then we need to create a vector called uv that is also empty. And then we're going to do our xyzdist function. And what that needs is a geometry stream. So where are we looking? So what we want is input, we want input 3, which in stupid computer language, input 1 is 0, this would be 1, and this would be 2. I don't know why they do that. They should just make it 1, 2, and 3. It's so fucking confusing. But input 3 is actually number 2 in stupid computer language. Okay, so number 2. Okay, and then what we're looking for is we're just trying to see the distance, just p, how close it is. Prim, put our empty prim there, and uv. And what that's going to do is it's going to whatever it pulls back, it's going to take this p and store it in these two. Okay, then we need to create a float called mask, and that is going to be equal to, and we're going to use our prim uv, and we're going to put down 2 again. We're looking, and then mask, that's the attribute we want to pull from that, and then prim and uv again. Okay, so now basically what we've done is we've had our geometry, or had our constraints look at the geometry here and figure out what parts of the mask are closest to it, and then pull that attribute onto it every frame. And now that we have that stored in a float called mask, we can just type So if we hover over this rest length scale, you can see the parameter is actually called rest scale. So we just do rest scale, and then we're going to go equals, and we could just do mask. We could just say it equals mask, but this is a 0 to 1 fall off. So that means that these parts that are black are going to be, the rest length is going to be 0. So it's going to like instantly deflate into nothing, and this will inflate into a lot. But I want to have a little more influence over that. So let's do fit 0, 1. And then we're going to go where the parts are 0. I want them to be 0.3. I don't want them to be all the way 0. And then where the parts are 1, I want it to be 3.5 in rest scale. Okay? So let's see what that does. Let's just hit play and see if it does anything. It's doing something. There we go. It's doing it. Let me just do a little quick flipbook so you can actually see. Okay, so we got our flipbook here. You can see it's doing exactly what I want it to. Now it's absolutely crazy. But what we're going to do is, you have all these jaggedy, shitty looking edges. It looks kind of crappy now. But if we use a time remap and slow this way down, which we're going to do, and then we can just subdivide all these crappy edges to make them really smooth, it's going to look awesome. But it's really cool. It's like they're fighting with each other constantly. You can see the black and the white are moving around. They're dynamically creating this like insane, almost fluid-like organic looking thing. Now it's kind of weird that this thing is happening. It's like this actually came loose somehow, which shouldn't happen. That didn't happen in my original one. So you may need to play around with some substeps, maybe add another substep or two, or you may need to, reposition these so that they're maybe like a little farther away from each other. Maybe they're a little thicker. I know something else we could do is things you can adjust here are like, let's go to the distance along geometries. We can bring these all in like this so that it's much sharper. So that'll have an effect. You think other things we can do, we can adjust the mask. So it's, you can make these numbers, the black areas don't go down quite as much or something like that. Let's try, maybe let's merge these so I can see them. Let's take this guy and move it like all the way over like that. And then then we've changed our little sharper mask here. And let's just see if that does anything differently. I don't really want them to pinch off like that. I want them to stay together. But the cool thing is that since these rings are interconnected, they basically, they can't get away from each other. So they're constantly like fighting and expanding and contracting, but they can't just like fly off into the distance. They kind of stay centered. So you have this like really cool looking thing. And you can also add in stuff. You can add in pop forces too. I think I did something like that in my, let me do that here. Just add just a little bit of a pop force. So pop force, where is it? Here, and plug this in the center guy here, the part of the forces. And let's give it just an amplitude of 1. Why is it a 1? Just 1. Let's give it a swirl size of like 1.67. And yeah, I don't know. Let's just offset it a little bit. Oh no, not the turbulence. God, what have I done? 3. It's just something like that. Okay, and then let's just run another little flipbook, and hopefully that fixes the little pinching off thing, because these should just stay together. I don't know why I was doing that. My original test version didn't do that. So you may just need to kind of play with the positions and stuff. Okay, so check it out. Now I've got a new one. Seems to have fixed the problem. Cool. Okay, so I'm going to cache this. So let's call that good. And let's come back up here, Vellum Sim. And let's just put down a Vellum IO like this. And we'll go put this in my job folder. And yeah, 240 frames is good. Let's just save the disk. forgot. With Vellum Bio, you need to plug in this as well. And then, yeah, I think that should be it, right? Let's try that again. There we go. Okay, now it's going. Got to plug in the constraints. Okay, now we have it cached. You can see it's working. And I think I didn't really change much. I didn't need to use any other sub steps. I think just kind of moving my little toruses around a little bit just kind of helped. So cool. This is looking nice. So now what do we do? So we're going to time remap this. I want this to loop infinitely, and I want this to be really slow as well. So let's find a point. I don't want to even see the part where they even look like toruses. I want them to start like here. So let's say, let's put down a time shift, and we'll do, so the frame 18, $F plus 18. Okay, so now it just starts from there. Cool. Great. Okay, now I want this to be really slow. So let's put down a retime. And let's go, let's see. How many frames do I have? I think I just want the retime from like, oh, why is this? Oh, right. Because let's do like to like 144, something like that. And then let's do the speed like 0.09. Let's see what that looks like. So now that's really nice and slow. That's looking good. Okay. So maybe let's do like frame 200, something like that. Okay. So now how do I get this to loop? I want this to loop infinitely. So what I'm going to do is I'm going to find a point that I like. So let's basically have it start. We need about a, I think this goes a lot longer than 240 now, because now that we've slowed it down, let's go this to like 500. I think we have a lot more frames now. Oh yeah, way more frames. Okay, so what I'm going to do, let's go like 700. Let's see how much we have. Oh yeah, we got a lot. So we need to find areas that kind of look similar to one another, and we're going to use a blend shape to blend them. So I think where the mass is sort of concentrated here, maybe like around frame 120, I think would be good to start. And that gives us kind of like a 120 frame runway. And then let's find a frame where the sort of concentration of mass is sort of in the center like this. And that'll be our blend point. So let's say like here. Yeah, so maybe like frame 600. And then so we're going to start at frame 120. And we have 120 frames to get there. So let's say 600 minus 120. That would be 500, be 480. Okay, so let's do a time shift here. So basically at frame 600, I want this here to look exactly like frame 120. Okay, so 600, what is the math? 600 minus 120, it's 480. So let's do F minus 480. So that should look just like that, and it doesn't. That is so strange. Okay, 120. What am I doing wrong here? Nope, I had it right. Okay, so if I click here and I go to frame 600, okay, I have this shape. And then if I go back to 120 and click on this one, it's the same shape. Okay, so now what I need to do is put down a blend shapes. Okay, and plug this one here and this one here. And what I want to do is starting at frame 480, I want to blend shape here. And then I want to go to frame 600 and go like this. Okay. And then, so now if I run a flipbook starting from frame 120 and ending at frame 600, I should have a complete loop. So let's try that. 120, 600. Oh, it should just be an infinite loop. Okay, so let's see what we have here. So let's check this out, starting at frame 120. It's going nice and slow. Okay, that's looking cool. Great. All right, we're coming up to frame 160. Here comes the transition. And perfect loop. Nice. So it works. Now you may need to play around with it a little bit. So the reason you want to have them kind of have a similar shape when you're blending it, because if I blend from this point to this point here, there's going to be a lot of like really noticeable intersections. So you kind of want the mass to be a somewhat similar shape and size. It'll help kind of hide the intersection, because you can see there's a little bit of intersection there, but we're not even going to notice that. I want this to this is going to be kind of an abstract thing anyway. Okay, great. So now we have our infinite loop. Cool. Now what do? It still kind of looks like garbage. So we're going to want to smooth this out. So like these areas here, so we can put down like a subdivide to kind of, or we can do like a vellum post process. And let's just do Catmull Clark, give it 2 subdivisions. So now it's looking a lot better. We can do like a detangle maybe, or like a spatial blur. That can kind of help. I like the really fine wrinkles though, so maybe don't do too much spatial blur. Something like that kind of helps with the intersection. You can even do extrude by thickness. And that might help. That helps a lot of the intersections there. If you want it to be like that, I left it like this, and I actually didn't even use a vellum post process. I'm just going to do this all in Redshift. Okay, so let's find a nice moment like here. Okay, and let's come up, and we'll do a little bit more like lighting and look dev and stuff in the next one. But I just kind of want to put down a quick camera and a light on here. God damn it, camera! Why can I not type? Jesus. Okay. Down a camera, look through it. Let's go like this. Maybe let's make it more like, let's give it like a longer lens so that it kind of flattens everything out. Kind of turn it like this. And we may have to animate our camera because this kind of like moves around a lot. I had to kind of animate my camera a little bit, just barely, just to kind of follow the center mass. But something like this, probably maybe even closer. So I just want this to be really abstract, where you have like no idea what this really is. Okay, and then let's put down RS Light Dome. And then I think I just used, there was a Grayscale Gorilla, like their creative spaces thing. I just used this creative office thing. And then let's just fire up the render viewer. See what we get. Okay, so here we are. Looks like garbage. Let's maybe in our camera, let's do, or our that camera, let's do optical. Let's bring the exposure down a bit so we can actually see this. So that's looking pretty cool. Nice. Okay, and we can maybe kind of move this so we can get a little bit more dynamic lighting. That looks pretty cool. And then let's remove turn off the environment. I don't want to see that garbage in the background. And then I forgot to do the tessellation here. So let's pause the render, go to your Vellum Sim here, go to Redshift Object, Tessellation, enable smooth tessellation. Now, start this up. There, now it's nice and smooth. And then I think really all I did was, let's do go to Material, put down an RS Material Builder, call this Shiny, and throw that on there. And then all I did, I think I just basically did like a really basic metal material. So just crank the metalness up. And then for the color, remember we still have this mask attribute, which we have been outputting. We used a pop color to turn it into CD. So we can use that. We can do RS point attribute, and we can plug that into the base color, and we'll have to refresh this, of course. So the areas that are like more inflated will have a different color than the areas that are less inflated. And we can put down a ramp like this and make this one be like kind of a something like that. And then we'll make this one be more kind of pinkish, pastel pink, something like that. Cool. And then I think, well, I mean, I'll go into this more detail, but I also I kind of made a weird material. I made this like subsurface scatter as well. So, and then I think I turned down the base weight. What did I do? I don't remember. I'll cover it more in the next tutorial, but for now, that's kind of it for this effect. But yeah, that's the basic of the effect. It's really fun to play around with. Try playing around with like things that are interlinking that are not toruses. Like try with a lot more abstract shapes. You can try more than 3. Try like 4 or 5 toruses. Try changing the numbers. Try changing it so that it expands way more or expands way less. But that's the basics of how this effect works. And then, of course, you just kind of put your camera really close to it, and then you have this like really abstract, slow-moving, really cool-looking loop. So in the next tutorial, well, first, so let me just quickly recap what we did. We put down our 3 toruses. We made them interlinking. We turned them into balloons. We came into this vellum sim. We used a SOP solver to basically create these little masks so that they dynamically detect how close they are from each other during the simulation. And then we used the vellum constraint property. We used the XYZ dist. Basically, XYZ dist and PrimUV, it's the code version of an attribute transfer. That's basically what it is. It's just saying, look, it's telling the constraints to look at this geometry and take this mask attribute and copy it onto the constraints. That's all it's doing, just the code version of that. So we did that, and then we used that to influence our rest length scale. We slowed it down, retimed it, and made it into a fun infinite loop. So that's basically it. The next tutorial, I'll go a little bit more detail into lighting and shading and all that, and then I'm going to show you guys how to animate some little flowers, and then we're going to turn those into Redshift proxies and scatter like a bunch of them all over this thing. And we're going to use this animated mask attribute as a way to define where the animation is. So I want basically the parts that are white, I want my flowers to be fully bloomed. And then the parts that are red, I want them to be like not bloomed at all. So as this moves around, my flowers are going to like bloom and unbloom along with the inflation. So that'll be a fun one as well. I hope you guys enjoyed this. Let me know if you guys have any questions, and I'll see you very shortly in the next tutorial.